Hey, Algebra 2 friends. Just checking in with a different version of simplest radical form. Um, it didn't go so well in the pair deck form, so we're going to try it a different way where you can follow the steps along, but if you feel stuck, it's not all or nothing. So this is a question from yesterday's pair deck. Uh, the square root of 500. And so we're going to take this one from the top. We're going to follow the 3 steps, factor tree, write it as a multiplication problem under the radical, and then reduce it. So as we go along, we're going to ask you some questions in hopes that you can pick up a few points along the way. All right, so first thing we're going to do is we're going to break down 500. And you're going to have to ride this train with me because I'm going to make a lot of the choices and then you're going to tell me what comes next. So if I'm looking for 500, my mind immediately says 5. 5 times what? So you're going to quick answer that. Hopefully you said 100. Okay, so it's 5 times 100. So how do you know when to stop factoring on the tree? When if you tried to factor it, the only thing you could come up with is that it's itself and 1. Like if I tried to factor 5, it would be 5 and 1. You can do that if you want, but over time, we tend to just stop with that. This is what we call a prime number. That's the only number that goes into it is itself and 1. So we're going to stop there with the 5. But we can keep going with the 100. And so now I'm going to say 100 is really, and it is really up to you. A lot of people, I don't know, over the years have said 4 and 25. So that's what I'm going to go with. So 4 and 25. Now, at this moment, you have to decide, is 4 prime or can you break down 4 further? The answer is that 4 is not prime and it can be broken down further. So we're going to do that. And as far as that goes, we're going to go 2 times what? Hopefully you said 2. All right, now is it prime? Yep, 2 is the only prime number that's even. That's exciting information you should never forget. All right, so we have the ends of our tree, our leaves here. Now we're going to go for 25. And how would you break down 25? All right, hopefully you said 5 times 5. And both of those are prime. So we now have our prime factorization. Probably studied it earlier when you were younger. Maybe they didn't call it that, but that is the name of it. All right, we're going to take just the ends of our tree leaves here, and we're going to go. I normally like to group them by number. So 5 times 5 times 5 times 2 times 2. And so that you don't forget, this is still a square root problem or a radical. And one of the things we've talked about is that there's a secret 2 right there. Now, mathematicians are really lazy. We don't like to write it. Also, part of the reason we don't write it is because back in the olden days, it was really hard to type a tiny 2 right there. So if there's no number there, we assume it's a 2. We assume it's a square root. Now, this is going to tip us off to what we should circle. So maybe this is the part where you got stuck yesterday. You're looking for pairs. That's because it's a 2 on the outside because we're looking for squares. So I see a pair of 5s, and I tell people, like, whoever's ready first gets out. So this 5, sure, it's a 5, but you only get 2 of them, so I usually just take the first 2. All right, so there's a pair of 5s and a pair of 2s, and when I take them out, what I'm doing is I'm taking the square root of them. So 5 times 5 is 25, and the square root of that, square root of 25, is 5. So you get a 5 on the outside. So we represent, excuse me, the pair on the outside like that. And then 2 times 2 is 4. The square root of 4 is 2. So we have a 2 on the outside. Now we don't have a 52 on the outside. We just have a 5 times 2. And 5 times 2 is what? 10. Your final answer is 10 square roots of 5. And again, this is a concept that was in geometry, so this isn't new, but it may feel really new to you, just depending on what days in geometry you're there. 10 square roots of 5, or 10 times the square root of 5. And that's how you do it.